Start again. A very good evening to you all. It's Jordan Bridge, Deputy DCFI at Lasham, with the communications webinar on the BGA Bronze syllabus. Communications is one of my speciality areas, but of course, the winter months now, it is a good time to get these exams done, and I believe there'll be a couple more presentations like this over the winter, starting with this one, and then in a couple of weeks' time, we've also got Michael Harrison, who helped me put this presentation together, do one on air law. For those of you who haven't been to Lasham, it's quite a unique place, as you can see, with airliners and gliders cooperating quite happily together. So it is the perfect place to talk about communication. So just some sort of housekeeping, hoping to keep this to about an hour, but if it does overrun, my apologies. You can ask questions throughout. I believe there is a question icon at the bottom, and you can just click that, write a question. Might be better to leave questions at the end, and there are just a few practice questions that I put in at the end of this this presentation. But without further ado, we'll make a start. And in the typical EASA way of doing things, we're going to have a look at the learning objectives. So we're going to understand the law in respect of the use of VHF radios in the Airband spectrum, understand the basic functionality of a radio, look at the different sort of issues that we might get with the radio, and especially being in a glider, as you can imagine, there might be a few extra ones. The type of airband frequencies, and just a little bit on the theory of radio, as well as a bit of radio telephony and distress calls. For this presentation is very specific on gliding towards the end when we talk about sporting frequencies, but a lot of this will also be useful if you are doing a PPO or you are doing a TMG conversion motor glider, simply because we do generally use the radio a little bit more there than we do in the gliding world. With the law, and that's what we've got to start with, is unfortunately the boring bits. Ofcom regulate the civil radio spectrum. So this is something which has been going on for a long time, but the CAA and Ofcom have been sort of fighting out a little bit over the years to try and work out who should look after what. So at the moment, Ofcom regulate the civil radio spectrum, and they do all of the administrating of licenses for stations, and they collect the fees for that. They do not, however, do the licensing for glider pilots or power pilots. That still remains with the CAA, and we'll have a look at what they get up to. Because they do delegate quite a lot of that, because Ofcom are not experts in aviation, they're just experts in radio. So Ofcom have a look to see what sort of the sort of general broad radio licensing should be, and the CAA go in and have a look to see what stations are good, what equipment should be used, and there's obviously different standards that need to be applied within aviation, and we use specific bands. And that's airband spectrum does remain with Ofcom, and we'll have a talk about sort of where that band is, because as you listen in your car, you're listening to, normally if you're on FM, somewhere between 88 and 108 megahertz, the airband spectrum starts slightly later. So we'll have a look at where that does start and what frequencies sorts of work. Right, a bit more on the law. It's not as if people get prosecuted for these a lot, but there are various acts and communication roles that we must keep aware of. The Wireless Telegraphy Act does say it is an offence to install or use a radio without a licence. So this is where at times you might hear us sort of say, well, if you don't have a flight radio telephony operator's licence, or the FRTOL as it's called, that you cannot use a radio on the airband spectrum. That's because it's on the Wireless Telegraphy Act, and it sort of looks to see who should and who should be using a radio, because there has to be a minimum standard, or we'd all be doing sort of naughty things. That is sort of kept separate from what's known as CB radio, citizen band, which allows people to use the radio without a license. But as you might know, if you have used sort of walkie-talkies, they are on very, very specific channels, and sort of in a built-up area, you might find a lot of people using them. I know school dinner ladies like to use that, as well as maybe supermarket security staff. So CB radio is kept very, very separately because of the fact it allows people to use the radio without a license. But for what we're doing, which is airband and proper radio, Wireless Telegraphy Act does require you to have some licensing in place, both for the equipment and for the person. Communications Act 2003, I haven't really read it. It's quite a long document, but it defines Ofcom's roles and the powers in regulating the spectrum. So it will be something which is given by Parliament to Ofcom in order to get on with that. But the most important document for us is CAP 413. Now, CAP 413 is quite a bit of bedtime reading. It's quite a few hundred pages long, and it goes across all of the different scenarios and phraseology that is used within aviation. Within this, you'll find bits that are to do with big jets, there'll be bits to do with propeller planes, there's bits to do with airships and balloons. But there is, for the first time in recent years, I believe this year, they've just put a bit in for gliding, and I'm very pleased to see that, because air traffic and gliding have been always a little bit separate because of our sort of non-reliance on radio. But with changes coming afoot, more introduction of controlled airspace and more legislation and licensing coming forwards, we as glider pilots need to sort of incorporate ourselves into the rest of the aviation world. And in doing so, we need to make sure that we know what we're doing. And by having CAP 413 with a bit of gliding specific phraseology, it means we have a clue where we're going. Because for years before that, we've had to use quite a lot of information which is just relevant to the propeller plane sort of markets, and we've had to edit it to make it work for gliding. But with a good understanding now between what gliders need and what phraseology is required, we're now at a stage where gliding is looking more incorporated than ever into CAP 413. So yeah, those are a bit of legal bits and bobs, but the main one to look at there is CAP 413, which we'll have to talk about a little bit later. Okay, a bit more on legal. We will get through this. All equipment must be fitted with a wireless telegraphy act license if it's fitted to an aircraft or used to transmit messages to an aircraft. So if you are operating an airfield, you have to have a license if you have a specific frequency. So Lasham, being a busy gliding club, does have its own frequency, which we pay for, which is 131.030. And in doing so, we have to make sure it's licensed. Now, for clubs that might use some of the other frequencies, there are a couple, and we'll come on to that later. I think sort of clubs such as sort of the Mind, Seifert, etc. They will have frequencies which are sort of banded together and are basically looked after by the BGA, because if we all went out and got a station that would talk to aeroplanes, we all got our own frequency, you can imagine for the amount of gliding clubs in the country, that would be quite a lot of frequencies that are required. And for the amount of gliding that some of the smaller clubs do, it's a lot of money and it's not actually that much worth it. So that's why you'll sometimes find there are common frequencies, which we'll come on to later. But in the general sense, we need to have a license if you're an airfield that is having a frequency for itself. And if you're fitting some equipment to an aeroplane, you need to have relevant paperwork for that as well. So those two types, as I said, the aircraft fixed radio license and the aeronautical ground station license. Portable radio is always a bit of an interesting one. They can be used as a backup radio if it has already a fixed radio license in. I am aware at times that when radios break, we go and borrow the handheld, etc., etc. But we should never become entirely reliant on handhelds. When I've gone to trade shows and spoken to the big names like ICOM, they are very clear to say that because normally these things will only come undone, let's say, if there's an accident or something like that, and you want to make sure that you're always above the law. So backup radios and handhelds are good. But if you are going to use a handheld full time, you're going to need to look for a license for that potentially as well. That goes the same for whatever setup you might have for a gliding club. So at Lasham, we have a handheld radio and we also have a base station. And both of those have to be on our approval to provide to have a radio frequency. So yes, need to look at licenses. But as I said, a lot of legal stuff, but as you can expect, we don't go lightly on this because the gliding does need to fit within the rules. Okay, almost there with the legal stuff. All persons operating on an airbound radio frequency must hold a FRTOL, or Flight Radio Telemetry Operator's License. This is kept very separate from if you're operating on BGA sporting frequencies, which we'll come on to later. And that's where you can see this exemption here. You do not need a license if you are talking to not talking to one of these. So if you're not talking to an air traffic control or flight information service or a ground service, a communication service, which we'll come on to a little bit later, we do not need to use, we do not need to have a license as such. And that's some freedom that we've kept within the BGA for a good number of decades now. And it's served us well. But as I say, with more incorporation of gliding and aviation, we're getting to a stage now where we do need to get these licenses, because we do occasionally need to speak to one of these people. It might be we're just passing by a small light aircraft strip that has an air-ground communication service. It might be we're passing somewhere like Gloucester, which has radar traffic or procedural traffic being positioned onto an ILS. It's important that we communicate, and it's important we do it legally. If you're operating as a student pilot, you can operate under the sort of radio license of somebody else, so your instructor. Same as if you imagine you're borrowing the license of the instructor when you are flying solo. No matter sort of which way you look about it, when you go solo, you're not a licensed pilot, and sometimes that area is kept a little bit vague for some reason, but it's very, very clear. The BGA definition is bronze and cross-country endorsements, or if you hold a sailplane pilot's license or sailplane flight crew license, as it's now being called. Obviously, there's lots and lots of transitions and things changing at the moment, but those are the definitions of being licensed. So if you're below that, then you can borrow somebody's radio license if you're under their specific authorization and supervision. If you're above that, then you need to get onto a stage of having a license or not operating on controlled frequencies. Of course, nothing stops an emergency. If you do have an emergency, and we'll look at the emergency procedure a bit later, we will obviously, you just do what you need to do. Okay, what I'm going to do, I'm just going to pause the presentation a moment because I'm just going to try and get the animations to work. So just bear with me about 30 seconds and I should be back. Right, okay, can we all see a presentation? Can we see it full screen? Lovely. Okay, fantastic. For some reason, I couldn't get the animations to work on Click Meeting. I'm more experienced with Zoom, but I think we should be good on here now. Just means that we won't spoil any surprises when we get on to the topic of the practice questions. But I think everybody can see me, so we will make a start on it. So, okay, finding your way around the radio. So, first of all, one button in particular not to touch is this button here, the settings button. Your club engineers or club CFI will know what they're doing with this. It has lots and lots of functions for squelch, as well as sort of what audio function it might be coming out of, what speaker. So please do not touch that button unless you know what you are doing. You then got the on-off button. Easy to say, but we have had students in the past not know where this is. It's not particularly, let's say, the best named button, but yes. Obviously, we're just looking at say a funk work radio here. So these are the ones that are fitted as standard into Lasham ones. Other ones may vary, but the general principle is still the same. So on-off on these, you do have to hold down for a couple of seconds. It does not necessarily come on immediately with the electronics of the glider. And there's a good reason for that. If the glider's sort of been parked up or is just being got out of the hangar and stuff, you don't want it draining the battery too quickly. So things are generally kept on isolated circuits. You've also got dual watch. Now, dual watch is a very interesting function. What dual watch allows you to do is allows you to listen to two frequencies at once. So what we can see here is at the moment we're listening to the primary or actual frequency, of 136 decimal, just bring up the laser pointer, 136.935. Now, that's the only one the radio is listening to at the moment, because on the standby frequency, you can see we've got 123.450. The standby frequency is there so that you can sort of change it about to get the next frequency you might want. But the dual watch button is very, very useful because it allows you to listen to two frequencies at once. So by pushing that button, the standby becomes DW, this area here. By listening to two frequencies at once, it means you could potentially listen out on your local gliding frequency, but maybe if you're close to another airfield as well, you might be listening to their frequency too. Now, as I say, we're trying to operate in a world now where we're trying to get better situational awareness. You can get that via things like FLARM or Pilot Aware or sort of Sky Echo, all of these conspicuity devices which allows you to see where their aircraft are. But radio is still a really important a really important aid to helping us sort of see and be seen, because if we can hear that there's lots of traffic going around an airfield, we can know what to look out for. So dual watch is probably the best function that's been put on radios recently. Not all radios have them, but generally it's a standard feature that is coming out now. So pushing that button allows you to listen to two frequencies. Just quickly on what would happen if both frequencies talk at once. The top frequency will always be the one that it is listening into the most. So if this one's transmitting, or if this one is a message is picked up on, and the top one here is picked up on all of a sudden, then it will block out the standby or the bottom frequency, because that is the second priority one. So yes, don't necessarily expect to hear both messages at once. It'll all be very garbled, and you can change them around, and we'll come to how we do that in 8 minutes. But yes, it will decide which one you are listening to based on what is going on at the time. So this one will always be the primary one. You can only transmit on one frequency when this is happening, and that's always going to be the top one as well. So you cannot dual transmit as such. There are sort of more complex radios that some of the powered aircraft use. You'll sometimes hear people refer to box 2 on a radio, and that's because the radio has an ability to transmit on two frequencies at once. So it's much, much more complex. Glider radios are generally kept very, very simple. Volume. Volume obviously controls how much noise you get out of the radio. In the gliding world, we just need to be very, very careful that we don't turn that volume down too much when, let's say, we're trying to pre-flight brief and stuff like that. We need to make sure that it is kept at a respectable volume for the whole flight. It's very easy to be on the ground wanting to contact a glider, and the reason that you can't contact the glider is because somebody switched the volume all the way down to 1, and pretty much if you've done that, then you can't really hear anything and the radio is almost useless. So do make sure the volume is at the right setting. Frequency change is done by these buttons here, and in doing so, when you push this button, it moves this little line here across to the right. So you'll be able to change the big numbers first, so 1, 2, 3, you can change to 1, 2, 4, 1, 2, 5, or 1, 2, 2, etc. You push this button here and it moves that little line under there across to the, probably on these sort of radios now, it might bring just onto the 4, and then you would change the last couple of digits. There's been a lot of changes within radio spacing as they've tried to put more frequency or channels onto the spectrum. So with that in mind, do make sure that you are being very careful pushing these numbers in, because you might miss the digit out. But yes, you push that button there. You push that button there to move the line across, and you use this twisty knob here in order to change the numbers that you want. And those numbers are always on the charts or on a frequency guide that you get on a map or from the CAA website. Local frequencies generally you should keep sort of as either a memory item or maybe written down somewhere in the glider. Frequency switchover is here, and that allows you to change between the bottom frequency and the top frequency. So you might get this frequency ready, and then you change over to this one. That will go up there, and then this frequency will come down, and that means that you can start changing for the next frequency that you might need, because you might need a few on a cross-country flight. Okay, functionality very quickly. Standby for radio should be 90% of the time, so it's not listening, it's not receiving anything, not transmitting anything. especially for a glider which is relying on a battery. If you're transmitting or receiving lots, then you're going to be using lots and lots of power. In doing so, you're going to drain your battery. You'll drain your battery more when transmitting because it takes more power out of the system, but you still will a bit with receiving. So the radio sort of is working on an idea that's 90% standby, transmitting for 5% and receiving for 5%. When you receive, you'll obviously hear anything that's broadcast on the selected frequencies, and you could be wearing a headset if you're flying a motor glider, or it'll just come out through the speaker, as you can imagine. Background radiation, you'll hear a sort of squelch. That's that sort of background noise, all that hissing that you might hear. Old TVs used to do that as well. The squelch function on a radio, which is generally, if it's a club glider, should be set by somebody that knows what they're doing. Sort of enables the radio to decide when to start giving you to start sort of transmitting that information to you. The radio receives lots of information, but if you were to listen to everything, you would hear a lot of background radiation. So with that in mind, the squelch function is there to block out some of that unwanted background radiation, and you can sort of adjust so you can make sure you're hearing everything. If the squelch is too high, then that will mean that you hear too little, and you might miss radio transmissions which are maybe further away. Too low, you get all that background radiation, and it just becomes a pain. So yeah, those are the two things to look at with squelch. Transmitter, normally a button on top of the stick. Sometimes they're on a panel. On our K13s, they're in a panel. Obviously, that's generally fitted by the by whoever your glider is looked after by, or if you do the paneling work yourself. But generally, it's on top of the stick. Trial lessons generally think that it's there to fire missiles or some other exciting thing, but no. Button is normally on top of the stick. Be very careful. One I hates at the launch point is seeing a parachute resting on that push to talk, because that means everybody can hear you doing your straps getting in, and it blocks the frequency for everybody. So yes, be very careful of getting in the way of that button. If you're not pushing the PTT, nothing is received by the microphone. So either the microphone that's on your headset, or if you've got a boom mic, which most gliders do, nothing is received if the microphone is if the button is not pushed down. You can get times where the microphone might be broken. Now, if that does happen, as you push that button, the glider will transmit a carrier wave. So it will send out some basically information, but it won't have any sort of anything useful come through it, because as you talk into the microphone and it modulates, it sort of puts that information into the radio wave. If you do not have a microphone that's working, there's nothing to be modulated, and you get a carrier wave, which just sounds like a bit of sort of blank. There's nothing there. But of course, if you do push the PTT, push to talk, and you've got your microphone working, then you can get it working nicely, and the carrier wave is modulated for sound and transmitted exactly what we want. So sometimes you'll hear people going, that's only carrier wave only, and that is caused by the fact that your microphone might not be working. Now, a little bit on radio waves. Amplitude is sort of this bit here, the height of the wave. As I said, I think we've potentially been seeing a few too many of these diagrams, not in a radio sense, with sort of curves and things like that. But yes, amplitude, as you can see, the crest of the wave and the trough of a wave. The wavelength is the distance between the two, and as you can see, time goes on like that. And the frequency of the wave is sort of how long it takes to go from one part of the wave, at this part of the wave, to the next part of the wave, which is at exactly the same point. So yes, radio waves look like that. And when we get onto modulation, we look at something like this. Now, frequency modulation, and modulation is basically encoding information into the wave, because a sine wave, which looks like that, is great, but it's not actually giving us any useful information. If you just use it on its own, it will just sound just like background radiation. So by modulating the wave, that will mean that you can encode information into it. Now, I'm not a radio expert in terms of the actual very technical side of it, but my understanding of frequency modulation is that you encode information into the wave by varying the instantaneous of the frequency of the wave. So you change how much frequency there is in that wave. FM is less prone to interference, but it doesn't really work quite as well over long distances. So that's why you'll find when you're going up the say the A1M, you'll be able to listen to Radio 5 Live quite easily on the AM frequencies, but you might need to change a lot of the time the frequency on your FM radio as you go between stations in the area. FM though does provide better bandwidth, and with that provides better sound quality because you've got a bit more sort of spacing. It's less likely to be interfered on by the frequency next door, which with aviation, as we operate on amplitude modulation, is much more of an issue, and they've been trying to fix with trying to sort of give a bit more space between frequencies and try to make sure that not everybody's sort of in the same areas using very similar frequencies. Right, okay, on to the next bit. Amplitude modulation is where we vary the height of the wave, and you can see that very nicely there. So you encode all of the information that the microphone is providing into the wave like that. But AM is a slightly older way of doing it. It has poorer sound quality, but it's able to go that much further. And for aviation, we need that because of the fact that sometimes you might be some distance from the station that you are talking to. Radar units in the UK can cover many hundreds of miles at times, depending on where you are. So to have a AM frequency rather than an sort of using amplitude modulation rather than a frequency modulation works a lot better. It does mean with lower bandwidth you can stick the stations together a bit more easily, but as I say, there is more chance of getting a bit of interference between them. It is a cheaper way of doing it. It is old school, but it does seem to work pretty well in aviation. Comparison to modulation then, so just looking at amplitude modulation, as you can see, we are varying the height of the wave compared to frequency modulation, where we're varying what the frequency is. So, and that just compares to a sine wave that you can see there, which is, if you didn't do any modulation, what it would look like. Okay. Very quickly as well, the electromagnetic spectrum, back to sort of GCSE or sort of CSE O-level physics that you might remember. The radio spectrum operates anywhere between 1 kilohertz and all the way up to 100 gigahertz. We operate aviation generally within here, VHF, civilian aviation at least. That seems to be the most practical area for us, and it delivers what we need when we're operating, especially in land-based sort of scenarios. So when you're speaking to a local radar unit, very high frequency does work, and that is between 10 megahertz and about 100 megahertz, give or take. High frequency, which is has been in use for quite a long time in the aviation world, but is starting to sort of come out, works much better for sort of long distance communications. And back in the time where you had sort of Boeing 777s go, or Boeing 747, 707s going across sort of large areas of the Pacific and stuff like that, you would use high frequency waves, which are easier to sort of bounce off a layer of the atmosphere called the ionosphere, which is in the atmosphere. The waves could travel a lot further, and you could communicate back to land stations or other airplanes a lot further away on high frequency radio. That is now being replaced by sort of data link sort of text messages that you could send to airplanes. So that's working very nicely now. And HF is starting to sort of take a bit more of a back seat. Before HF, we actually had Morse code, and that was in the time where you would navigate via the stars as well. But for what we do now in sort of general aviation and gliding, we're using the very high frequency part of the spectrum. The military do use UHF. That's a little bit easier for them to use. I believe they might also put a bit more securing into their communications as well. So if you are landing at a military base, or you operate from a military base, some of the helicopters might operate on a completely different frequency on the UHF spectrum, despite the fact they're talking to the same air traffic controller. You just can't hear them because they're on another frequency. So yes, glider radios are always operating on the VHF spectrum. Hey, again, simultaneous transmissions. If you do transmit at the same time, if somebody hits the push to talk and somebody else does at the same time, you get a lot of garbling that happens on the frequency. So the transmissions may not be heard and the person you want to talk to may not be aware. So when we come on to the actual practicalities of actually using the radio, please make sure that you're not talking over somebody else. And when we come on to messages being given between sort of radar units or controllers and gliders, don't butt in on that happening, because it can make it very frustrating and just make the whole sort of conversations longer for everybody, as people have to ask to be heard again. Bit like if you've got lots and lots of people talking in a restaurant or somebody butts in, it just doesn't work. We've only got 2 ears. So simultaneous transmissions not something that's particularly good. Radio range is generally line of sight in the VHF spectrum. So that works that, let's say, if you're on the ground stood on one side of the airfield, you can probably quite easily talk to somebody on the other side of the airfield. But let's say if you want to talk to your friend, this is just generically speaking, not a situation we necessarily use, but if you were talking to somebody who's in a town, for example, maybe 5 miles away and you're on the ground, you won't really be able to speak to that person because the line of sight isn't there. And for VHF, you will not get that, you'll not be heard. If you're in an airplane, though, 1,000 feet higher, you have the benefit of having longer range. And that works with this little formula here. 1.33 times the square root of aircraft height plus the square root of receiver height. Now, that's not a calculation I've ever seen actually put into a bronze exam, but it is a very useful one to remember when we're thinking about how far we might be able to talk. If we're scratching low level in a thermal about to land out, and we're talking to our mates who have been flying with all the way, they might not be able to hear you. Let's say if they've got sort of 20, 30k ahead because you're down low, you'll be able to hear them, but you might not be able to transmit to them. So you might not be able to say that, oh, I've landed out. So don't necessarily worry if you don't hear anything from people if they're down low. They might land out and they might just need to send you a text, which you can't read in the air, of course, but they'll need to find some other way of communicating, because if you're down low, you might not be able to get that range to the airplane that you want to speak to. So yeah, just think of that. Line of sight is what is the best way to think about how the radio works. Now, how do we look at failure on the radio? Quite often I'll get told the radio doesn't work. Now, that's a very generic way of saying it. How might we deal with that? Well, the first thing is the radio on. I've already shown you how to do that. Does the glider have a battery fault? That's very easy to tell, because if the FLARM isn't working, or maybe some of the other instruments are playing up, then we're not going to be able to get any response out of the radio either. You might find that as you transmit and the radio draws more power from the battery, you might not be able to get, it might cause the radio to trip, and that might be a sign that you need to change the battery. As a rule, really, you shouldn't be keeping the glider batteries in for more than the day. Back about sort of 5 or 10 years ago, when we had less kit in the gliders, there was the ability to do that, but with all these complex variometers and conspicuity devices, power is now sometimes in a bit of short supply, so make sure you do charge your batteries up, otherwise you might not be able to use the radio. Volume's another one. We did mention the fact that you do need to make sure it's up. If it's down, there's no point. Squelch, making sure that you can hear everything. Frequency, if you dialed the wrong numbers in, then you might be either speaking to somebody else, you might be speaking to Heathrow Tower rather than Lasham. Does happen quite a lot that people get on the wrong frequency in all walks of aviation. I've spoken to a number of jets inbound to Heathrow who've got the frequency confused when they've been given it, so make sure you've got the right frequency as well. You might find the push to talk doesn't work, or maybe you're leaning on it. You might be out of range. There might be conflicting sort of radio traffic, but the best thing to do, old British sort of way to fix things, reset it, turn it off, turn it back on again. If you've still got radio faults, you might want to look at how the microphone's been rigged up. You might need to see if anybody's messed with the settings. But diagnosing failure is something that we need to do with our heads screwed on, because it's very easy just to go, oh, something doesn't work. Well, why isn't it working? Don't just report it to the engineer, expect them to be able to deal with it, because we need to get a little bit more information than that. And when you're flying the airplane, that's the best time to be able to find out what the problem might be, if you do have one. Okay, two bits of the spectrum that I said we're interested in when we talked about the VHF is between 118 megahertz all the way up to 137 megahertz. Now, with this in mind, this is the communication area. So this part of the frequency, this frequency spectrum, as if you remember back to how we spoke about Ofcom, has been delegated by Ofcom purely for aviation use, but in the term of communication. So that might be used for balloon to retrieve car communication, that might be used for air traffic control, might be used for gliding clubs. So that bit there is used for that. Navigation is still, which we do still have radio navigation in use in the UK, though it is being slowly phased out, uses a different bit of the spectrum from 108 to 117. So if you somehow manage to tune up your radio to do something very fancy, then you might be able to listen to a VOR, but in most senses, car radios can't do that. So VOR, DME, or sort of beacons such as this are all on those frequencies. We don't really use that in gliders because we're not needing to navigate via that, but VOR and DME sort of beacons and sort of working out how far you are away from the beacon are things that do exist. Your airband radio will not normally be able to tune into these things. I believe some of the very fancy handheld ones can do both if you're wanting your handheld radio to tell you where the beacon is. But for glider radios, we're really interested in the communication area, which is here. Right. Types of airband frequency and people that you might speak to. This is where we start getting a little bit more interesting. Air traffic control it's a very sort of broad term, and not everybody you speak to on the radio is an air traffic controller. You're not normally going to find air traffic controllers running gliding clubs. People that deal with big jets, sort of big airports, so the Heathrow's, Gatwicks, your Birminghams, your Gloucesters, etc., will be fully licensed air traffic controllers. Now, these people can basically tell airplanes what to do, give them instructions, no matter what phase of flight they're in. And air traffic controllers will have a number of different call signs. Air traffic controllers might be called ground, they might be called tower. Approach, let's say if you are operating near Gloucester, for example, which a lot of gliders go past, Gloucester approach is the air traffic control call sign because they're dealing with all airplanes in the vicinity of them. Director might be somebody who is positioning aircraft to space them out, a bit like Heathrow. Heathrow director is a person that makes sure all the airplanes in a non-COVID time will squidge together as close as possible to make sure there's sufficient runway sort of capacity. If there is not somebody who's doing that, then obviously the airport might get over capacity. There's the broad term of radar that sort of covers a lot of these ones. So you might find that radar is the same as approach and director, for example. You won't find that radar is doing the same job as tower most of the time, however. Zone seems to be a more military term. When Farnborough came into effect, they did actually initially call it a zone frequency to get access into their zone, but they're normally now radar is their call sign. So zone is normally a military one. Control is normally sort of higher up in the sky where we're dealing with aircraft coming in and out of big airports when there's lots and lots of ones. So London Control, for example, deal with anything that might be operating in and out of London airports, and you get other areas of the London sort of workforce which are also working with aircraft much higher up at 30,000 feet and stuff that might not even be landing in the UK but do require some form of air traffic control service. So air traffic, you won't speak to hugely in a glider in most scenarios, but those are the different names of who you might come across. Below the rank of air traffic controller, you'll sometimes find airfields operate on something called a flight information service. This person can effectively tell airplanes what to do on the ground, tell them where to taxi and stuff like that. But in the air, they don't have the powers of an air traffic controller. They can only sort of advise, provide information of what is happening in the area. So it might be a flight information service officer, which is the role that this does, might say, well, there's 4 gliders out to the west reported on the frequency. They can tell the glider, or motor glider, let's say, maybe to taxi to a certain place on the airfield, and that instruction does still sort of stand. But when you're in the air, you're sort of on your own as such. It's down to you to make the decisions. The flight information service officer can only provide so much information, and you must do whatever you see fit with it. Now, below that, you have air ground communication service. In its normal sense, discounting Lasham, because Lasham has a very unique air ground communication service. Air ground effectively is just a frequency where most of the time the aircraft are just saying what they're up to. So it might be that you're saying you're on your downwind leg, or you're about to take off. There is no instructions that an air ground communication service can provide. It's basically somebody that is just the middleman on the frequency, the central point. They'll be able to provide you information on what the surface wind is. They might be able to provide you the local area pressure setting, but they can't sort of tell you to taxi over here. And if you hear of a ground communication service, let's say Popham Radio, for example, which is a local airfield near to us, you need to know that requesting clearance for takeoff isn't going to work, because they cannot give you that. They're not licensed to. They're just there to keep an eye on sort of the flow of the traffic around the airfield. Below that, you have common traffic advisory frequency, which is a bit like if you're operating out of a very small grass strip, there is a frequency called safety comm. And safety comm is basically where airplanes just talk to each other. There's nobody sort of mediating the frequency. You just say, right, okay, I'm final for this airfield, and many other airfields will also share that frequency, because the common traffic advisory frequencies are not designed for busy airports. You will not find Heathrow operating on that. It might be at times that, let's say when Lasham is quiet or there's no gliding going on, that Lasham, though it does sit within this area, air ground communication service for a lot of what it does, if there's no gliding going on or no jets taking off or landing, it becomes a traffic frequency. So you just make blind calls as if there was somebody there. If you get a reply, that's great, but if you don't, it's nothing to worry about as such. Finally, your sporting frequencies, like your BGA ones, are effectively without a call sign, so you can just chat on there. Okay, radio call basics, phonetic alphabets. I think most of you will know that. Just make sure that you've got the correct one. When you are making a radio call, say the individual digits. Don't just put it all together, because otherwise somebody might not be able to get the message across. Speak, and I'm probably not doing this very good in this presentation, at a normal speaking volume and pace. Don't talk too quickly. Push to talk 1 second before, hold until 1 second after. If you push down and just as you're doing that start talking, the radio's not had time to activate the microphone. And if you lift off too early, it might deactivate the microphone a bit early. So make sure that you are pushing the button down at the right time. Think about what you're going to say before you talk on the radio. There's nothing worse than somebody blocking it up because they've forgotten what they're going to say. Keep it concise and make sure you have an idea of what you're asking for or wanting to know. Don't interrupt conversations, I've said this before, unless it's urgent, like an emergency. And when you do change frequency, make sure that you have actually listened out before you start talking. It might be the controller is busy doing something, talking to his colleague or on the phone with somebody. So it might be that just because the frequency is quiet does not necessarily mean that there's nothing going on. The controllers are generally busier than you think. Okay, we're going to get on some practical scenarios now on initiating a radio call, and this does come up in the BGA Bronze papers. So when you are going to talk to somebody, and it's going to be the first call, you need to know who are you calling. So get their attention, get their call sign. So we're going to use the call sign in this of Farnborough Radar, which is our local radar unit at Lasham. So we need to know who we're talking to. So bit like talking to somebody on the street, you go, "Hi John, who are you calling? Who are you?" So, "Oh, it's Jordan." You then, so in an airplane sense, you'll say, "Right, I'm Golf Charlie Lima Uniform Delta, or Sierra Hotel 7, depending on which one you're going to use. Generally, legally speaking, you should use the G-Reg. You can use the prefix glider as well when you speak to somebody, when you're identifying yourself, so that when you're calling up, they know that they're not speaking to a powered aircraft, because these registrations are seen quite a lot on powered aircraft, and there's no sort of differentiation between them. And once you have said, hello, I am this, you need to say what you want. So keep it short, very concise, and then that gets the station that you're going to speak to ready to be able to get an idea of what you want. If you provide them all the detail at once, then they won't be able to process it. They need to be ready. It might be the controllers writing down on a strip or on an electronic board on what you are wanting, if you're wanting to go into controlled airspace, for example. So don't just throw all the information at them at once. It doesn't really work. So we're going to look at a practical one. I think this one still has the old Farnborough terminology in it. So Farnborough zone, that's who we're calling. Glider 775, so we've said who we are. Request zone transit, so we've asked to go into the controlled airspace. Very, very simple. Who we want to speak to, who we are, what we want. We might transmit to somebody else. Let's say we're going to speak to OGM, another local airfield. OGM approach, another frequency. It's an air traffic controller still. Glider 431. Now, if it's something more complex, like you've let's say seen a field that's caught a light near the airfield, you might want to call them up and give them time to respond to you, because if you just say, oh, there's a field on fire, they might go, oh, well, maybe you're on fire. So give them a chance to respond if you've got a more complex message, because they won't be necessarily ready to write down for the information. So OGM approach, Glider 431, simple as that. Now, we've asked Farnborough to reply with a message. So Farnborough are ready to respond to us, and they're going to say Glider 775, Farnborough radar, pass the message. And what that means is the controller is ready to hear sort of what you want and what you're up to and who you are, a little bit more detail. But they can say Glider 431, OGM approach, standby. Now, standby is a really, really key word here, because the controller at this point is not yet ready to deal with your inquiry. They will call you back when they are ready to accept that message. If you get 5 or 10 minutes along and they still haven't replied to your message, then maybe call up again and remind them, but don't bug them to call them back, because they might be busy. You might find there's actually an emergency going on somewhere else on the airfields, which they're dealing with, and not on that frequency. So as I say, don't presume the controllers just because they're quiet are not busy. They are indeed. They've got a lot of tasks to deal with which us pilots cannot see. Don't acknowledge the standby message either. It just blocks up the radio call, and standby is not a mandatory readback. Now, when Farnborough asks you to pass your message, you're going to give them some information. You're going to say who you are. You're generally going to repeat your call sign doing that. What you are. Now, generally in the context of gliding, we have a look at two sort of very generic terms: stand class, which is less performance than an open class glider. If you tell them you're a K21, I'm afraid controllers do not know the A to Z of gliders. They won't really know what that means. So standard class or open class glider works well. There is also vintage glider now, and for a controller, they've been trained to know that standard class gliders lose a medium amount of height, vintage gliders lose a lot of height, and open class gliders lose a less amount of height over a 10-mile range. They'll ask for your route, and you need to provide that. So let's say we're going towards Farnham. We're going to have a look at that in a moment. We provide them the routes. They need to know where you are, how high you are, what pressure setting you might be using on your altimeter, what you want again, what are your intentions, and say what you do want. And you need to maybe give a little bit more detail. So let's look at this in practice. Glider 775, or if you want to use your G-Reg, is a standard class glider, so you're giving them the information on what we are. From Lasham to Goodwood via Farnham, 1 mile, and we generally do work in miles of air traffic control, not kilometres, north of Alton. At 3,000 feet on the QFE, so field elevation above Lasham of 909 at 8 hectopascals. and request zone transit on track Alton to Farnham. So you can see we've given the information. The controller is now ready to see what he can do, or he or she can do. So what are they going to reply? Well, they're going to go glider 775. They're going to give you their pressure setting because, of course, it's their airspace, it's their area. They need to make sure everybody's at the right heights or altitudes according to the regional QNH. So QNH 1018. If you've got a transponder, they'll ask you to squawk a code. That means that they can see where you are on the radar and they can identify you based off that. It might be that you don't have a transponder and you might have to respond to them saying negative transponder. Basic service, which effectively means that you're just being provided with information relevant to your safe conduct of flight, and they're going to give you an instruction because they don't yet are ready to let you into the airspace. They'll say remain outside controlled airspace. Now, that is an instruction there, and when we do have instructions, we need to be able to read back them so the controller is aware that we have fully understood. Mandatory readbacks may include, or do include, pressure settings. So if we've been told that's the pressure setting, 9 hectopascals, the controller wants to know that you're going to plumb that into your altimeter so that you're not going to bump into the airspace because you're on the wrong setting. They want to know you're going to put the right squawk code in if it's relevant. Headings, if you're told to fly a heading. Levels and altitudes. So if they say you cannot go too high, you need to be able to tell them that you know that. Speeds, not normally relevant to gliders. Clearances, so if you are allowed into the airspace. Runways in use, if you may be landing at an airfield, and that goes a mandatory readback for any of the services. So an air-ground communication service, if they say it's runway 27 in use, you need to say, runway 27 with a left-hand circuit or whatever may be relevant. Circuit directions, because sometimes on some airfields you might preference a circuit direction for noise. The service level you may be being given, so it might be a basic service or traffic service or no service at all, and anything you're unsure about. So if you're unsure, just repeat back what they've said. It's a bit of sort of you hear me, I hear you sort of business. So so we know what we need to say back to the controller now, and in doing so, we're going to now repeat that information back. So as you might remember before, Farnborough told us all of the information. There's the mandatory back there, QNH 1018 and squawk 0456, and a couple of informations here. So basic service, remain outside controlled airspace. This one especially being the key one because we're not yet allowed in, despite the fact we're talking to them. So we're going to say QNH 1018, squawk 0456, basic service, Wilco. Now that Wilco means that you've sort of shortened the message. You will comply with the instruction they're given to you. You could say remain outside controlled airspace. It's generally the same thing. And then you finish by closing the message with your call sign so they know who they've got that from. Because if you are operating with a couple of people in the glider, let's say if the student's doing the transmitting, the voice might change because of the fact that you are, the student might make a mistake and the instructor might intervene. So they're not necessarily going to work it out on just the voice alone. So saying who you are at the end of the message is a must. Now, when we get clearance, which we hopefully do, and Farnborough are quite helpful with this, they'll say glider 775, cleared to enter controlled airspace, on track Farnham, remaining south of Farnborough Airport, not above altitude 3,000 feet. Now, it goes without saying, you just repeat that back to them. Cleared to enter controlled airspace, on track Farnham, south of Farnborough Airport, not above 3,000 feet, glider 775. Hopefully that seems sort of logical. So I haven't seen any questions yet, but we'll come to the end with that. We're not too far away from it. Useful tips. If you don't know what you should say, just use plain English. Controllers are only human as well. They know that if you have forgotten, just say it however you need to. They will always correct. They can always correct you or provide you with the proper phraseology. Don't be scared of air traffic controllers. They are human and they are there to help you. I know at times that people have a bad stigma that they don't want to help gliders, but they do. They have no bias in doing so. At the end of the day, they want to safely manage their air traffic as expeditiously as possible. They don't want to hold people up. There's no grudges. So don't be scared. They are there to help you. As I mentioned before, they may be busy, so do accept that. and there's a lot of work that goes behind the scenes. If you do, once COVID has sort of become easier to work with, if you do get the opportunity to visit an air traffic control facility, or even your local sort of flight information service or air ground communication service, have a look at what they do, because it's fascinating to see the other end of the radio, and invite controllers as well to see what you get up to, because they don't necessarily know the specifics of gliding or other areas of general aviation. And if you're unsure about anything, just ask, because there's nothing worse than accepting a clearance and you make a mistake and you might get, you could then get reported for it. Controllers are only going to report you if you've endangered safety or if you breached something. They have to do it. Again, it's not a grudge. At the end of the day, they're trying to keep things safe, and there are serious repercussions for them if a mid-air collision nearly does happen in controlled airspace especially. So do make sure that if you are unsure, just ask. You can have it repeated as many times as you want. So we've gone over this before, but the main things to recap: who you are calling, who you are, what you want. Later, who you are, what you are, where you're going, where you are, what you want. If you can't remember what you need to read back everything. Simple as that. Useful words and phrases. Affirm means yes, negative means no. Roger means I've received your message. Wilco means I will comply with the instruction if not read back. So you might be told remain outside controlled airspace. Now you could use Wilco to shorten it, but you could also say remain outside controlled airspace. Doesn't really matter which one you use, but sometimes to keep it nice and concise, you could use Wilco. Say again, very important one. If you have not heard exactly what you were told, you can ask them to say again, and they'll repeat the message. Unable, big one. It might be a controller asks you to do something that you cannot do. It might be you can't squawk, you say unable. It might be that they want you to go over to a certain place to go thermaling, but if there's no cloud there, you can't do that. So unable is a big, powerful word. Don't use it too much, but it is something that you can use if you are potentially being put in danger. Confirm can be used as well if you are unsure about the message you've been given. We'll just go into a little bit more detail about unable. If you have been asked to do something which is unsafe, and the controller isn't necessarily doing this on purpose, you are the pilot in command. You have to remember that controllers may not be pilots. Gone are the days, and it's very sad that controllers are not automatically given that much flight experience anymore. Now, that's just unfortunately because of budget cuts in the world we live in today. And that's why I say that any opportunity to get controllers flying should be taken, just as we should go and see what they get up to. So controllers may have never flown a glider before, and he or she might give you a clearance which is not suitable for a glider. They might say, can you remain not above 1,500 feet? Well, for a glider, that's not going to work, because you're going to be sort of going along at field height, trying to work out if you can stay airborne or not. So by using unable, you might be able to get the controller to rethink their plan, and normally they will. There's normally a good reason that if they can't, and it might be you need to change your route, and that's why we always talk about having a plan B instead of operating through controlled airspace if necessary. But a lot of the time, controllers are issuing sort of standard clearances, and they might have forgotten that you're a glider. So if you are unable to do something, say unable, because that is the key word. Readability, sometimes you might ask for a radio check. Lots and lots of different things to that you might be heard. If it's, hopefully as I'm talking now, you're hearing me, readability strength 5, which means it's perfect quality transmission. You can hear everything that's going on. That goes down to 1, where maybe I am talking it like that, or something like that. Or that might be readability 2. It's a bit difficult for me to improvise that. Carrier wave only might just mean that they can hear that somebody's transmitting, but the microphone is not plugged in, so they can tell that there's an airplane that wants to talk, but they can't actually hear what the airplane wants. And there is various sort of modes of failure that the controller can rely on using something called speechless code, which we won't go into today. It's more used in the flight radio telephony operator's license. But you could use speechless code to sort of provide a yes message by almost doing a bit of, not exactly Morse code, but using the button to basically spell out a message that you want to give to the controller. But yeah, readability, strength 5. Don't always respond with that if somebody asks you for a radio check. It's not just always strength 5. Sometimes the radio might be a bit crackly. So remember that. we get towards the end here, distress calls. Mayday, which comes from the French word midi, means there is imminent danger to life or the aircraft. So it might be that you have had a complete failure of the rudder. That is a big problem, and it might be that you might be considering jumping out or crashing somewhere. So Mayday is what you'll use if you're in imminent danger. If you are in a bit of a problem, but it's not life or death, pan works quite nicely. It might be in a pan scenario that you've had an issue with your instruments, for example, your UDI's failed and you've had a complete electrical failure and you're just using your radio and you're unsure of position, you need to find where you are. So pan works for that. Never be afraid to declare or over-declare an emergency. If you've got a problem, it's better to get the trucks rolling out the fire station and get everything ready to deal with the problem, rather than you end up in a field and nobody knows about it. You won't be criticised or penalised, and you can always downgrade or cancel your emergency if you fix it. It might be that the control eventually comes free as you wiggle your stick to try and get control of the airplane again, and then you can probably downgrade to a pan. But it'd be better to know there's a problem. So if the problem reoccurs, you're in a position where you've got some assistance. You've always got to say these things 3 times. It just means that somebody's heard, and it does stand out very nice in the frequency. So Mayday, 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 or pan. Take a look at a scenario with this. But who should you call? Not going to zoom in on what gliding club that was, but gliders do catch fire if you're not careful. You could speak to the people you're already speaking to. You could speak to distress and diversion cell, who are really good people I'll come on to in a moment. Or you could call the sporting frequencies. They will be able to offer, they might be called the sporting frequencies, but they won't be able to offer limited help. If there's loads and loads of gliders on the soaring frequencies and somebody's got a problem, well, there's nobody necessarily on the ground who's able to help. So do think about who you're talking to. If you've got your airfield frequency, or if you've got somebody, radar unit you're speaking to, then speak to them. If there's really a problem you don't need to speak to distress and diversion cell. It's a bit like the 999 of the sky. And they are on 121.5. It is intentionally still 25 megahertz, with the idea that all radios, no matter how old they are, can still tune that up. There's no radio license required. It's staffed full-time by Royal Air Force controllers down at Swanwick in Fareham, and their call sign is London Centre, but don't particularly worry about that. The UK is very lucky that we have the only sort of full-time distress and diversion cell really in the world that can do what they can. They can pinpoint where you are, they can get trucks rolling, and they can hear you across the UK. Other countries are not so lucky and just rely on controllers who are just listing it within their back ear to try and help those in distress. So 1215 is the one to use, and they do like doing practice ones. Have a look at what they get up to for a bit more information on that. Making distress call, as we say, Mayday, 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 London Centre, glider 775. You can give this information, as you say, the ailerons might have jammed. You might say, right, I'm going to land at Bryce Norton because that's the safest thing to do, and only ever do what is safe. You need to say where you are, a bit like this process we've followed before. You might say you're a student pilot. If that's the case, they might be able to get somebody with experience up into the tower to sort of help you out. And if you've got other useful information on board, maybe somebody's been, if you've been in a collision, somebody has been injured, they can get sort of specialist medical assistance to you where necessary. So yeah, there's your distress call, and just follow that information. So Mayday, 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 and all of that below. It's better to give too much information than not enough. Tell them what you need, take the safest course of action. Once you're in an emergency, everybody else doesn't matter as such. If you are speaking to distress and diversion, they'll coordinate. They may make suggestions, controllers may tell you what to do, might say, well, please don't land on the runway because that might stop big jets from landing, but if that's the safest thing for you to do, then you need to go and do it. Don't wait for permission, don't worry about the regulations. Emergencies absolves you of all of that. Just take the safest course of action. If you do hear somebody else in distress, then don't transmit, but maybe you might need to note down the details, because as you might remember, radio range does only work based on how high you are. And if a glider's down low, if you have got an aileron jam and it's going to have to crash in a field, then it might be the radar unit can't hear, and it does rely on the glider that's nearby to pass that message on. And that's very useful. We all need to look out for each other on that. and you just relay all that information across, and they'll be able to get the trucks rolling. Finally, sporting frequencies. So no radio license required, no controlling authorities, there's nobody sat in the middle policing what goes on. Talk in plain English, but please keep it considerate. It is quite funny what appears on this frequency, especially during the junior nationals, but we don't know who's listening, and the CAA could kick up a fuss if we were to be heard using these frequencies inappropriately. There are a few more frequencies to remember. These I would note down as rote learning, I'm afraid. 129980 and 118.685, common glider field frequencies, so frequencies you might use at your local gliding club. 130105 for situational awareness, bit of generic term. 130130 for cross-country training. 130535 for cloud flying, because there is a requirement to make a call on the cloud flying frequency before you go in. 129905 for ground to ground. And finally, 129890 and 130405 for coaching. This one does get quite a lot of use because it's very similar to the old cloud flying frequency. So you can use these frequencies for obviously just general chit chat. You can tell them how good the thermals are, how not good the thermals are. Do be aware that a lot of these frequencies may be used by competitions. So you don't really want to get on a frequency which is being used by Lasham or Husbos and stuff at the start of a competition, because competition organisers need to be able to hear from the gliders that are calling their start times or maybe their finish information. But yes, so lots of frequencies there to remember, and this presentation will be made available later. But if there's anything you need to remember, there's normally at least 1 or 2 questions on this in the BGA papers. Finally, Volmet, another useful radio sort of frequency to listen to, provides local weather information away from the sort of main weather frequencies that you might get. So Farnborough, for example, has its own weather station which transmits on 128.4. It's an automated voice saying what the wind's doing, the cloud-based visibility, rain, etc. Volmet, which is run by the Met Office and NATS and the CAA, effectively allows a lot of different airfields to report into one common frequency, and it's an automated voice telling you what the weather's like in Manchester, in Luton, in Southend, etc., so that you can make sure that you've got the right information that you need for your flights. And they're split up into areas. 1286 is London London South Information Broadcast, so that deals with everything basically south of Birmingham. 135375 deals with a much generic sort of UK, France, Netherlands, and the ones in between might deal with the north and the west, etc. Light signals do sometimes come up in the papers. I would suggest you have a look at the Skyway code to get a little bit better at this. For those of you that don't know what the Skyway code is, it's a CAA document, a bit like the Highway code, which gives all very useful bits of information on this sort of stuff, and that's a very good revision material. It is designed for glider pilots, but it is not designed for glider pilots generically. It's designed more for power pilots and helicopter pilots, but glider pilots can make use of it. But you can see all these different light signals where if you haven't got a radio or if you've got a problem, the tower can provide with a series of different light signals using a big lamp with a red, white and green sort of selector on it, can communicate to the aeroplane. So yeah, we won't go over that too much, but I do recommend that you have a look at light signals because they are important. You'll rarely see it done, especially for a glider, but it is something to know. Right, we're just at the end here. I'll just get I'll just have a look. Right, a few just practice questions just to go through. I'll give you a couple of minutes to have a look through and then we'll just finish up. But which of the following call signs does not comply with the phonetic alphabet? So have a look at that. Which of the following is a true characteristic of aeronautical VHF radio? And while flying, you note that previously busy gliding frequency you've been monitoring is complete silent. What should your actions be? At this time also, if you do have any questions, then please do ask and then we'll finish up. So just use the ask question button if you do need to ask one. Apologies, this has run on a little bit. I forgot there's quite a lot of things that are in this document. But better to go over it too much. then not enough, and then we shall finish up. You don't need to put the answers in the bottom. Keep it to yourself. We'll just give it a couple more minutes and then we will reveal the answers. Okay, I think that's just about enough time just to give you these are out just of the bronze confuser, so that they are questions that will still appear. Be aware that the bronze confuser is quite old now, so don't rely on it as the only source of information. But the answer to question 16 is C. Oh, no, it's not C, sorry. Somebody's messed up my, sorry, no, it is C, sorry, I read that wrong. Oscar Quebec Sugar, because it says does not. See, you can tell it's late at night with me getting confused. Question 25 is A, range to the ground station increases with aircraft height, and 27 is B. So making sure you haven't got your transmit button jammed in the down, because you might be blocking the frequency. There might be other reasons as well, but that's the answers. So I'll leave now if there's any more questions. Yes, Serena, go ahead with a question. And then I'll finish up with a few more useful resources which you might be able to use. Yeah. So good to see 29 of you on here. Yep. So Serena asks, how do you switch the standby frequency up to being the actual? I'll just go back. Ooh, probably lost my screen. Oh, there we are. Right, let's go back onto here and there. So you can see the frequency switch over button there, Serena. Hopefully that answers the question. You press it, yeah. You push that button and it switches the frequencies around. See, Desmond is typing a response. Yes, correct. There's no point trying to call somebody to tell them that their transmit button is put down. I've tried. It can work if you've got a radio that's strong enough or has enough power. So the radar units can overpower a frequency at times if they've got enough outputs. But yes, our normal handhelds can't really do it. I think I did, Serena. It just no. When you push frequency switch over, that on there, that does. I'll just bring up the pointer. Yep. When you push that, it makes the standby the actual. So 1, 2, 3, 4, 5, 0 would move up there. It toggles. Is that okay? I know it's late at night. Right. Okay. So thank you very much for joining me this evening. This is going to be a difficult time for gliding over the next few weeks, as you can expect. I will leave it to your individual clubs to let you know of what their way forward is. Obviously, it is a concerning time. We didn't expect to have the circumstances we are now in. Please continue to support your clubs. Your clubs continue to support you by providing bronze exams, sometimes over the internet as well. We have at Lasham provided that, and we will continue to provide that too. This is going to be the best time to do your theory examinations or get your theory done. So please just make sure you get it done. We'll be here to help you, and I'm sure many other instructors will be, and a number of more webinars will come up, and I'm sure that I'll make another appearance, because there's probably a bit less flying going to be happening over the next few weeks. But yes, as I said, a bit of an uncertain time. Apologies if I have been a bit stuttery. As you can imagine, I'm sort of reacting to the news as well, especially as this is my profession. But we are going to get obviously through this, and gliding will come back stronger. And for us, at least it's happening at a time of the year where we are not missing too much. We could have 3 weeks of rain for all we know. So, but please continue to stay safe. Look after each other, look after your clubs, and I will hopefully see you very, very soon in the skies in a way that is not so socially distanced when we're allowed to. And hopefully we'll have all the conferences and stuff, and next year will be truly the year that we've wanted for gliding. So if there's any more questions, then please do ask them. I can make my contact details available, or if you just get in contact with Lasham, they will pass you on to me. Normally I work sort of Sunday to Thursday at Lasham, but always happy to help, even if you're not a Lasham member. So that's it from me. Look forward to hopefully seeing you soon. Take care, and bye-bye for now.